Okay, today's January 24th, 2012. We're continuing with our exam review. The exam review asks us for the period and amplitude, so we need to find the period and amplitude of this function, which is y equals 4 sine x plus 90 minus 3. Okay? How far along the x and y axis has the wave moved from the original equation y equals sine x? So actually they're asking us for quite a few things. Okay? So they want to know, number one, the period, number two, the amplitude, and number three, they want to know how much it's been transformed up and down. Up and down. And left and right. Okay? So, what we're going to look over, first of all, because we haven't really dealt with any different cases of this, what is the period of y equals sine x?
360.
360. Have we ever learned where it was anything different from that when sine is involved?
No.
No. So, our period in this function is going to be 360. Okay?
That's one period.
One period is 360. We haven't learned a different case. Okay? There is a different one, but we're not covering it in this course. So lucky for you, if we're dealing with the period of a sine function, you know the period is going to be 360 degrees. Okay, the amplitude. Now, we talked about this the other day when we went to actually graph everything, but I want you guys to recognize, does anyone know what variable actually represents amplitude? The A, that's right. The A here represents amplitude. I think that's just coincidence, but I guess that hurts. So, in this case, our variable A is 4, which means the amplitude of this function is just 4.
There we go.
So is it always 4?
A. Always going to be our A, the amplitude. Okay? Now, if it's negative, amplitude deals with absolute value. If it's negative 4, do not put the amplitude as negative 4. The amplitude is just 4. We only deal with absolute value with amplitude. Okay? The negative deals with reflections on the xy axis. Okay, so we've dealt with period and amplitude. Now moving left and right and up and down. If you guys remember, this is our H.
Going left 90 degrees, and you're going down 3 degrees, and then you're stretching it.
Just close it. So what was our H in this one? 90. So which way am I moving?
Left.
Yes, that's right. Because it's positive 90, we're moving in a negative direction, 90 degrees. And our K, so we go down 3 units. Okay. So that's the answers for question number 8. Okay, so 9 deals with 4 different equations. They're all parabolas. So the parent function, or the original one, is y is equal to x squared. So I'm going to quickly just graph that one out for us. When y is equal to that, we know our vertex is at 0. We go over 1, up 1. Okay? Then we go back to the vertex count again. We go over 2, and we square that. So we go up 4.
Oh, this is for the original one.
Yeah, back to the vertex, go over 3. We square 3, we go up 9. I know, that's fine. If you only can put 2 points, 2 points is good.
Well, wait.
Okay, so there's our original one. Now we're going to talk about the different ones they've given us. A, in this question, is y is equal to bracket x plus 2 squared minus 3. Okay, so these are in vertex form. And if you guys remember our vertex form, y is equal to x squared plus. So we have our a value, our h value, and our k value. Okay. Is there an a value in this one?
No.
Technically there is.
1.
Yes, 1. Okay, good. So our a value is 1, but it doesn't really affect stretching, right? It's the same as the original. What is our h value? 2. Positive 2 is our h value. So which direction do I move the vertex from the original? Left 2. And our k value is negative 3. So we go down from that spot 3. So we go to the left 2, down 1, 2, 3. And we have our vertex. Because there's no stretches, it's drawn the exact same way, over 1, up 1. Then we go back to the vertex, over 2, up 4. 3, 1, 2, 3, 4. Over 3 from the vertex, up 9. So we have 3, 6. So our first parabola, which is in blue, is drawn right there. That's our A.
Why?
All right, question number, not number, 9b. They've given us a similar one. Y is equal to x plus 3 squared minus 2. Okay, again, we don't have an A, but it's not the same thing. Our H is a different number. What is our H in this version? 3. So which direction do we move the vertex?
3.
Left 3. And what is our K value? Negative 2. So we go down 2. So that means we're moving to the left 3. 1, 2, 3. And down 2. 1, 2. So the vertex of our red one is right here. Now we draw that function, go over 1, up 1. Back to the vertex, go over 2. Square 2 is 4. Back to the vertex, over 3, up 9. So the colors are corresponding to the functions. I know I'm not doing a great job of drawing them.
I know how you feel.
All right. So there we go. We have our parabolas. We've done the original one in black, A in blue, B in red. We'll do C in green. C is y is equal to x minus 2 squared minus 3. What is our H? Okay, so which direction do I go? I go to the right 2, the opposite of what number is in there. And K is negative 3. You have 4 different graphs. Oh, the continuation? Okay. 1, 2, 3, and down 3. You're right. So this is almost like a mirror image of the blue one. Same ideas when we draw it. Over 3. So our green one, we put there. And finally, D, which I'll put in black and then highlight it after, which will be quite a feat if I'm able to do this. D will be y equals x minus 3 minus 2. What is it? The same as what? What's the difference? Yes. Okay, different color is part of it. Our H is negative 3, so we move in a positive direction 3 and then down 2. Okay, so it's very much like the red one we drew. We just moved in the opposite direction when going through it. Move the 2 red ones. And they cross there. So our final black parabola. I'm really not good at this. We'll highlight it. I don't think that highlight works very well. Alright, and there's our highlighted parabola. So we drew 4 on the same page. There are slight differences, but each of those differences, whether there's a plus, minus, or moving the 2 numbers around, made a different parabola. I want you guys to make sure you recognize that. Part B, number 1. They're asking for the domain and range of this function here, which is f at x is equal to negative 0.5 x plus 2 squared plus 5. They don't really ask us about any other parts of this transformations. So for our domain and range, there's really going to be only 2 things that are very important. First off, what type of function is this? Quadratic, so the shape of it is what? It's a parabola. So it's either heading upwards or downwards. So, in that case, what is our domain going to be? That's right. Okay? Our domain is just going to be X, E, R. Okay? Yeah, there's no restrictions on the domain because it'll go left and right forever. Nothing restricts that at all. Okay, now for the range. There are two things that are important for the range. Okay, this is again in vertex form. The A is important and the K is important. Okay? The A, the actual number is not what's important. It's whether it's positive or negative. In this case, it's what? Negative. So right away we know which way it's facing is down. So that's going to tell us that it has a max. Okay? So in other words, we know that Y is going to be less than whatever this value is, the highest point. I can already figure that part out. Okay? We know that it's going to start off with Y, E, R, such that Y is a less than and equal to, and then this is where the K is important. The K value is the Y value of the vertex, right? So whatever our vertex is, we have our X, we know the Y value is going to be positive 5. So that means that is the absolute highest point, because this is a max, because it was a negative, the A, we know that. That's the absolute highest point. So that means Y has to be less than and equal to that number when we set up our domain and range. This question wants us to complete the square, which essentially means put in the vertex form. So complete the square. So remember, when completing the square, the very first thing we're going to do is we find the common factor between the first two terms. Just those. Yes. So 4 is a common factor. Sorry, not the common factor. We want to take out the coefficient in front of our first term. So negative 4, we're going to take the negative out with it to get a new A value. So the negative 4 goes outside of the brackets. And I'm left with x squared minus 4x in the brackets, subtract 5. Now remember, we always do that little side calculation. We take our B value, which is now negative 4, divided by 2, and square it. Negative 4 divided by 2 is going to give us negative 2. Negative 2 squared is going to give us 4. So we need to add and subtract 4 inside those brackets. Doesn't really matter. X squared minus 4x. Then we're going to add and subtract 4. So plus 4 minus 4, end brackets, subtract 5. Okay? But you can rearrange things as long as you keep the sign in front of it.
Ooh, something like that.
Yeah, I'll get to it. So, now what we're going to do is, remember, we're trying to create a perfect square trinomial, so I need to move the negative 4 outside of the brackets.
I knew it.
And when I multiply it by that, I have to, when I move it outside the brackets, I need to multiply by the A value, which is negative 4. So, now we'll have negative 4x squared minus 4x plus 4. Outside the brackets, what's negative 4 times negative 4?
16x. Positive 16x.
Plus 16. And then subtract 5. Okay. We can simplify the outside of this. So we have 4x squared minus 4x plus 4 plus 7. Oh, 11. What am I saying? So that now, what's inside the brackets, we're able to factor. Now, you could factor this the old way I showed you. Right? We find the factors of the first term, the last term, put them all together. But what we did was we created a specific type of trinomial. Yes. So we can actually find this very quickly by square rooting the first term and the last term. Okay? So when I find the square roots of those terms, negative 4, in the brackets, square root of x squared, square root of 4, 2. What sign do I put down there? Yes, because the 4x has a negative, we put the negative there. And then this is squared on the outside of the brackets, plus 11. Now I'm in my vertex form. Okay? Now I'm just going to reverse engineer this just a little. This factoring here, because you guys asked me why we did that. If you guys look at this answer actually means x minus 2 times x minus 2. And if you were to factor this the old way, those would have been the factors you got. But because they're the exact same number, we just represent them with a squared and only one virgin on it. Okay? Yeah, I messed that word up, right? All right. Number 3 says to find the discriminant. Okay? They've given you this function in standard form. 5x squared minus 4x minus 8. Okay? Now remember our standard form. We have y is equal to x squared plus x plus. And we have our a, b, and c. Okay? Now, the discriminant is a formula. It's essentially the formula. It's a part of the quadratic formula. It's the part underneath the square root. B squared minus 4ac. Okay? The reason we use that part is because in the quadratic formula, we're looking for one of 3 things. If it's a positive number, we can square root it, which will mean there'll be 2 roots. If it's 0, that means we only have to add or subtract 0, so there'll only be 1 number to work with, so there's 1 root. Or if it's negative, I cannot square root that number, therefore there'll be no roots. So, with our discriminant, we're looking for either a positive number, 0, or a negative number. These are our options. So, we take our b value in this case, which is negative 4. Okay? So, negative 4 squared minus 4 times our a value, which is 5, and our c value, which is negative 8. Then all we got to do is work it out. 4 squared. Okay, negative 4 times 5. Negative 20 times negative 8. Positive 160. 176. The number itself isn't that important for what we're doing, but it is positive. Therefore, 2 roots in this question. All right? Can you...